One of the really fun things about designing RC planes is that there are kind of like two design approaches you can use when you're coming up with a model. So one of them is like the traditional engineering model where you're very methodical. You define your light characteristics, cruise speed, you calculate its stall tendencies using the stability derivative method. Maybe you've got a beefy enough computer, or you're subscribed to some cloud-based service where you can even run CFD on it and put it in a virtual wind tunnel and really see what its aerodynamic attributes are. There's that method, the engineering method. Then there's the just wing it method, pun fully intended, where you just kind of have a general idea and you just design as you go. So this is one example of that. I really wanted to do something with an EDF motor. Electric ducted fan is EDF, and it's basically an electric jet. So instead of going with a propeller design, you actually have an impeller, and well, everything's black, so you can't really see it in there. Unless, is there a way for me to enable flash? Or here, maybe, you know what? Let me bring this closer to the window. There, now you can kind of get a look at the blades in there. So that's there in the front with the ESC and the battery all jammed behind it. Let me take this little band off. I printed this out of TPU, a flexible custom band there. And yeah, as you can probably just intuit from looking at it, the motor spins up, draws air in through this inlet here, and then ducts it through this like ventral exhaust shape. It's one of the really cool things about 3D printing is it enables you to really make like funky geometries like this. I ended up just cutting these manually just to get the servo wires in there, because initially these motors were supposed to be housed inside the body, but because the EDF comes back so far, I had to shift everything rearward. So yeah, another just great example of designing as you go. I've got a little squishy TPU insert in there that just like holds the battery in place. But you might note that it's pretty congested and jammed up in there. I don't have a whole lot of space up near the roof of that duct. You'd be totally right. I don't, and there's a lot of internal interference in the free stream of the air. So let me just slip this back on here. I don't have a cameraman today. So I tested this, and I will be uploading another video. I kind of visualized the airflow by just putting a wad of like printer paper that I lit on fire in front of it. It's really cool footage of like the smoke going in through the inlet and then out through the exhaust duct. But when you actually test the thrust output, the motor doesn't produce enough thrust to drag the plane and this little stand that I've 3D printed along the table. So I don't actually have an output for the thrust in like a unit like pound force or newtons, but it, just knowing that it's below the static friction between this lower surface and this table, yeah, that's pretty insufficient, at least for a standard hand launch, which is typically how I launch these things. Despite all of this under optimization, the fun thing about designing in this like freeform way is that you can always come back to a concept that you've explored this way and then actually use like that first method where you're like, okay, here's what the core design is. How do I eliminate some of the obstacles? How do I optimize things like intake air volume and exhaust speed, and like let's make the fuselage big enough near the tail and make sure that there are mount points internally for the motors so that they don't have to float around on the outside where their control wires are exposed, things like that. So yeah, sometimes I like to do things in an intentionally sloppy way, just so I can explore these concepts.